Hello and welcome to another video of Reigate Maths A-Level second year content. This video is focusing on inverse trig functions and not using them, because you should be familiar with using those already, but more looking at them as functions and as graphs. So what do we know about inverse functions already? Well, we know that an inverse function f to the minus 1 of x exists if f of x is 1 to 1. So let's have a look, just for the sake of argument, because this argument works for all the trig functions, at y equals sine x. Now we know that this graph looks something like this. And some of you may be able to see the problem. This is many to 1. Because we have multiple x values which all give the same y value. Many to 1. So, according to this, inverse trig functions don't exist, but we know they do because we use them. We know that we can solve trig functions using them, so they must exist. But what do we do? Let's think about what type of answer we get out here. If you try a bunch of different values of a in your calculator for all sorts of different angles, we're going to get out, to find different angles, we're going to get out a certain interval of numbers, or a certain domain. And it's this domain that gives us the one-to-one mapping that we need. You may already be able to spot or be able to realize what that domain is. Even if you're not clear, you can try and just stick some numbers in, things like 0.7, 0.1, minus a half, that kind of thing. Numbers that you know are going to work. And see what type of angles we get out. Now, for the purposes of this video, we're going to work in radians, but obviously it all works in the same way in degrees. So let's have a look at the sine graph here. So we can see that here's this many to 1 idea. We have many different values that will give us the same y value. So we need to restrict the domain to make it 1 to 1. And what domain are we going to use? Well, if we look, or if you try numbers in your calculator, you'll see that if we use this domain here, x is between minus a half pi and a half pi, we get every single y value of the range. Because that's the thing. We can't use this interval here, or the one I just showed, between 0 and pi over 2, because although this section here is 1 to 1, it doesn't give us the whole range. So we need this bit here. So we can ignore the rest of it. Which means we have endpoints. What does an inverse function, or how do we get from a function to its inverse? Well, we reflect in the line y equals x. This line here. What does that do to our coordinates? If you don't remember, go back and watch the video on inverse functions. that should explain it. What happens is the coordinates swap over. So this point here, pi over 2, 1, is going to map to a point here-ish, 1 pi over 2. Likewise, this point here is going to map to the point -1 minus pi over 2. So something down here. And all the other points reflect. So we get this graph here. This line. This is the graph of y equals inverse sine of x. And notice it has endpoints. The endpoints are 1 pi over 2 and -1 minus pi over 2. You need to know the endpoints of this graph. You need to know that it doesn't just keep wibbling up and wibbling down infinitely. I discussed this a little in the previous video on reciprocal trig functions, or the previous few videos on reciprocal trig functions, that there's this kind of misconception with trig that sine to the -1 is the same as 1 over sine. That's not the case, and typically, nowadays, sine to the -1 is synonymous with inverse sine. However, there is alternate notation that you need to be aware of. And it's using this word arc in front of the trig function. Okay, so arc sine x is the same as inverse sine of x. You need to be aware of this notation, but it tends not to be tremendously used in the maths A level. Those of you watching who do further maths, this is a very useful notation to be aware of, and you'll use this a lot more. So, we know that the graph of sine inverse sine x looks a little like that. And has endpoints at 1 pi over 2 and -1 minus pi over 2, which makes it very easy to work out the domain and range. The domain is the x values, and the range is the y values. This should come as no surprise to you, because don't forget, when you go from function to inverse, the domain and range swap over. And the domain of sine is that sine x is between -1 and 1. We can work out inverse cos in exactly the same way. So we need to think, what type of numbers do we get out when we type in inverse cos on our calculator? And what will give us a 1-to-1 function, while also giving us the entire domain of y. Sorry, the range of y. And if we look at the graph here, you can see it's this section here, when x is between 0 and pi. This section here is what we want. So likewise, we've got 2 points which the coordinates are going to swap over. So this point here, 0, 1, is going to map to the point 1, 0, so down here-ish. And pi -1 is going to map to the point -1, pi. So up here-ish. And we end up with this graph here. Again, labeling the endpoints, very important. 0, 1 and -1 pi. because that could well be a question in the exam. Draw the graph of y equals inverse cos of x, labeling clearly the endpoints. So you need to learn them. It also makes, again, working out the domain and range very straightforward. The domain is between -1 and 1, and the range is between 0 and pi. Very simple. Tan is the more complicated one. So we've got the graph of y equals tan x here. It's a little easier to see where our one-to-one function comes in, because we've got this repeated element. So it's just this section here about the origin. The easiest way to think about drawing inverse tan is think about what happens with the asymptotes. So the asymptotes are at x equals pi over 2 and x equals minus pi over 2. When we reflect in the line y equals x, those two asymptotes become y asymptotes. So our graph of inverse tan is going to be strictly between, y is strictly between minus pi over 2 and pi over 2. The bit that I find tricky to remember is which way does it curve. So we can see, if I put this line back in, y equals x, we can see that the graph of tan for x is the positive side of things, curves away from this straight line here. So the same thing is going to happen with arctan or inverse tan. It's going to curve away from the axis. And likewise here it curves away negative, it's going to curve away here. So we end up with this shape. And we have to draw on the asymptotes. So this is the graph of inverse tan x. Again, drawing the graph makes it relatively straightforward, so work out the range and domain. The range is strictly between minus pi over 2 and pi over 2. The domain is any real number, because this keeps going, as you can see. Thanks for watching.